now do you have any doubt? Or I have given some of the questions which were related to the previous uh, first day's lecture, like census versus sampling and all those things. Have you attempted those?
मैम वो
यस मैम
होमवर्क मेरे
कर
पास
लिया
नहीं है।
मैंने, पर न्यूमेरिकल्स नहीं किए जो थे।
Numericals so we'll do afterwards. I have added all the simple random sampling questions for all the years that I have got. We'll do them one by one. That is, I have given in the one portion only. So we'll do them. And the derivation portion also you wouldn't be able to solve them. So we'll do them as and when we'll do them. You try them. Okay. So I have given for all simple random sampling with and without replacement, numerical plus theoretical portion and derivation portion. All of that I have given. So as and when we'll be doing those topics, you can solve them simultaneously and send me the results. And also, if you are having in any doubt, suppose today we do estimation, and if you have any doubt in problem solving or of that part of numerical solving of that portion, then in the next day's session, in the for the first time when I ask you, do you have any doubt, you can ask me that these are the doubts and we'll solve them. If it is common, we'll solve them on the board, and if it is not common and only one is having one doubt, then I will send the solution to him on WhatsApp. Okay.
मैम वो क्वेश्चंस हमें नहीं भेजे गए थे।
और पीडीएफ आपके पास नहीं आई?
सैम्पलिंग वाले की पीडीएफ शायद।
See, this is the PDF that I'm talking about. This one.
अच्छा मैम पीडीएफ बता दो मैं देख।
So at the end of the PDF, because the class ended at this one, so at the end of the PDF there were many questions. I think you didn't see them.
मैम पीडीएफ हमने नहीं देखा क्योंकि उस दिन हमने नोट्स बना लिए थे। मेरा क्वेश्चन
So in every PDF I provide you with some questions, so keep that in mind. Okay. So today let us do a quick revision of sampling errors and non-sampling errors. PDF you must have seen, Manik, you were not there in that session. Have you seen the PDF?
Yes ma'am, yes ma'am.
So let us do a quick revision of these. There are two kinds of error that we usually talk about. One is sampling error and the other is non-sampling error. Satyam, would you like to tell us what are sampling errors and what are non-sampling errors?
हम सैम्पलिंग एरर मतलब जो हम सैंपल करते वक्त जो एरर हमसे जो है हो जाता है वो सैम्पलिंग एरर है। और नॉन सैम्पलिंग एरर का मतलब कि जैसे फॉल्टी प्लानिंग, नॉन रिस्पॉन्सिबल या कोई बायस, जैसे जो जानबूझ के जो एरर हम करते हैं तरीके से, वो नॉन सैम्पलिंग करना है।
Some deliberate step that we have taken in the sampling method, that is known as non-sampling method, non-sampling error. And when the error occurs on itself without any deliberate step or without any intentional cause, then that is known as non-sampling error. So to differentiate them, one is deliberate, which is non-sampling error, and the other is random, which is sampling error. That these two words, if you use in the definition, then you will get marks. Now, first of all, discussing about sampling error is the faulty selection of the sample. So what do you mean by this, Manik? Tell me.
मैम एक सैंपल जो पॉपुलेशन को अच्छे से रिप्रेजेंट नहीं कर रहा, तो
whenever I'll be asking you that what do you mean by this, give me an example to explain it, so that the ones who will be seeing the recorded lectures, that topic should be clear for all of them as well.
मैम जैसे क्लास की हाइट, बच्चों की हाइट का सर्वे करना है, तो बस लड़कियों की हाइट ले ली तो पूरी क्लास को नहीं रिप्रेजेंट करेगा।
Yes, so that will be a faulty selection of sample, that we have taken only girls' height. Then that again, second is substitution. What is meant by substitution? Tell me. Anyone can tell.
सबसे वन हो जाए
मैम सब्स्टिट्यूशन का मतलब जैसे कि कोई डेटा हमारे पास मिसिंग है और उसमें हमने अपनी तरफ से कोई डेटा ऐड कर दिया,
And
जैसे
that
कि
too
किसी
unknowingly.
अननोइंगली।
जैसे कि
मैम लेकिन अननोइंगली में एग्जांपल
अरे मतलब we add that data that we think would be useful or in general common for those kind the survey that we are doing, but that cannot be true for everyone. Like I am surveying, let us take an example of cancer patients only. If I am surveying for the cancer patients, about the cancer patients, and one cancer patient didn't tell me that at what stage he is, so considering that I am taking only cancer patient 3 or 4, or 3 or above stages, then I can write in that portion I will fill 3 or 4 above stages unknowingly, that I don't know at which stage he is. This is not a deliberate step because we are carrying the survey on all those patients which are at the stage 3 or more than 3, and that is why we have substituted with 3 or more than 3. It might be wrong for that particular patient, so that can be an example of sampling error due to substitution. Okay. Then faulty demarcation of sampling units. Tell me what is meant by this. Manik, tell me.
मैम जो सैम्पलिंग यूनिट्स हैं उनको अच्छे से डिफाइन नहीं किया गया, तो
Example.
फिर
Tell me the example, Satyam. Faulty demarcation of the sampling units.
मैम अगर हमें मान लीजिए पटियाला के किसी जो कॉलोनी में सैम्पलिंग करनी है और हमें पता ही नहीं कि वो कॉलोनी कहाँ तक है, कितने घर उस कॉलोनी में आपको मिले, हम बगल वाली कॉलोनी में भी चले गए तो
Understood, Manik, or shall I tell you?
अंडरस्टूड मैम।
Tell me then what have you understood?
मैम मतलब कि जिस यूनिट्स का सैंपल करना चाहिए था उसका नहीं करके किसी और यूनिट्स का सैंपल बना लिया।
Demarcation is boundary. When we don't have a defined boundary of, suppose we are taking the same example I'll take that I took of the class time. So when I talk about demarcation, so suppose we were talking about that we have to measure of Patiala. So this is, suppose the map of Patiala, I don't know it, I'm just drawing it. This is Patiala. And on the side of Patiala, which city or town is there? Tell me. Manik, you live in Patiala.
मैम चंडीगढ़।
Okay. Then Chandigarh is there. Chandigarh is a little bit smaller than Patiala. So this is Chandigarh, but there is no demarcated boundary in our sample. So we take the population, some population from here also. So that is a violation of our survey, and that is how, when there is no demarcation in population or sampling units, then we just take some other portion sampling unit which shouldn't have been taken by mistake, obviously. So that is how, because demarcation are made on maps. When we calculate the actual areas on the land, there might be some mistakes that people can do while selecting the sampling units like this. This can also be taken for the forest or anything like that, the sample when we consider them. Then the fourth portion was improper choice of statistics. What is meant by this? This year, none of the question came from this particular topic, I think, or it came, I don't know. So mostly that I remember that it didn't come from any of this topic. So it is very important topic for the next coming year, because alternatively it has been asked every year. So this revision is very beneficial for you if you do it. Revision on the whole is very beneficial. So tell me, improper choice of statistics. What is meant by this? Satyam, we have done this. Tell me.
जैसे मैंने आपको बताया था ना कि अगर किसी शॉपकीपर को जूते अगर
Hmm.
रखने हैं तो और उसे पता है कि मतलब अ, उसे पता करना हो कि मतलब हमारे दुकान में ज्यादा बड़ी दुकान उसकी नहीं है और उसमें हमें जूते रखने हैं, तो वो सोचेगा कि अगर हम मीन एवरेज का इस्तेमाल करें कि भाई एवरेज साइज क्या है, तो
Hmm.
उसमें वो जो है सभी लोगों की डिमांड तो पूरी नहीं कर पाएगा। लेकिन अगर वो
Hmm.
मीडियन का इस्तेमाल करे कि मतलब 50% पॉपुलेशन इस एरिया की क्या जो है
Hmm.
साइज रखती है, तो वो
Hmm.
50% के लिए अगर वो अपना स्टॉक जिसे कहते हैं इन्वेंट्री वो फुल करेगा,
Hmm.
तब उसको फायदा हो सकता है। पर अगर वो एवरेज लेके चले कि 5 फुट 5 इंच के वे साइज रेट के जूते हम भर दें, तो कितना ही बिकेगा उसका। तो वैसे ही सैम्पलिंग में
Yes.
भी है,
Hmm.
हम इसमें मतलब चॉइस ऑफ स्टेटिस्टिक्स में भी कुछ ध्यान नहीं करा सकते।
If there has been a choice between mean, median and mode, depending on the data that we are calculating, if it has to be chosen as median, but we choose mean as our statistic, then our final result of the survey will be wrong. That is what Satyam wants to say. Understood, Manik? Wherever you don't understand, stop us then and there and ask us. Okay?
Okay, ma'am.
Now this is non-sampling errors. Non-sampling errors usually result due to deliberate or intentional things, or is not directly related to samplings, or some other is related to some other thing, like faulty planning. If our plan is only faulty, that we have planned to take the survey of objective, we have taken to take the survey of stage 3 or more cancer people in Patiala, but we are now, after that we are making wrong questionnaire, or we are choosing wrong areas or something like that. Whatever steps come in planning, if even one of them is wrong, then that comes under faulty planning. Now talking about non-response bias, what is meant by this? So Manik, we have talked about this in first lecture, non-response bias.
मैम जब कोई रिस्पोंडेंट रिस्पॉन्स नहीं देता या एब्सेंट होता है सैंपल से,
Yeah, then that is known as non-response bias, because some of the respondents might not respond, and the whole survey result can become biased due to some particular non-respondings, or even if we fill. So that we'll discuss later. Then errors in coverage again comes under that, when we deliberately cover other areas and not my own area. So I gave this example. So if there is this is my area where there is good people living, or good lifestyle, people having good lifestyle living is represented by G, people having moderate lifestyle is represented by M, and people having poor lifestyle is represented by P. And I have to show to my senior that my area is very well dwelling, and I take it from only good or moderate and do not represent poor people. Then my final result of the survey will be very good. So errors in coverage may come under this, and this also can come under bias selection of samples that I am doing. Okay. Though we don't have any raise hands or something like that option, so that I know. But I'm not getting any sound with this, Manik. No sound is there. This platform is not good. Then comes inadequate training of the personnel. So suppose that I am the personnel who is going to take the questions. So I should know how to ask questions, and how to fill the questionnaires, and how to make them understand to a layman, because we will be mostly talking to laymen who won't be understanding the reason why we are asking those questions. So training of the personnel is very important. If that person is not trained well, then our whole sampling survey will be will result in negative or some other results. Then compiling error. What is meant by this compiling error? I have written wrong spelling of compiling here, I can see. So what is meant by this, Manik?
मैम जब डेटा को कंपाइल कर रहे होते हैं तो कुछ उसमें उसके प्रोसीजर में कोई गलती हो जाए तो एरर आ जाएगा.
Yes, and can you give examples? Satyam, give us example of compiling errors.
हम अगर कोई गलत सॉफ्टवेयर लगा दिया उस डेटा को समराइज करने.
Yes, that can be one particular case. Then we can use compiling error. So you don't have to just write the headings in the examination. Why are we discussing them? So that you can fill in the information when you will write it, when you will be answering for this particular questions. Then comes publication errors. So when we are publishing our final result of the survey, then there might be some publication error, some typing error, or there is some words missing, such that I missed here while publishing this compiling error, I missed I. So there might be some cases. So suppose there is that there are 15k people, that example that day I gave, there are 15k people of third having third stage cancer in Patiala. But instead of writing this, the printing error or the publication error prints it just 500 or prints is 15 lakh or prints is less or more than that, then that can come under publication error. Okay. Then there are measurement error. What is meant by measurement error? Satyam, tell us.
हम मेजर करते समय गलती कर दी.
Example.
मैम स्टूडेंट्स की
जैसे
हाइट की यूनिट जैसे अलग यूज़ कर ली, फीट की जगह सेंटीमीटर यूज़ कर ली, पर उसको कैलकुलेट फीट के बेसिस पे कर लिया.
अगर सबकी सेम करिए तो फिर तो मेजरमेंट एरर नहीं है ना. तो फाइनल आंसर, अगर हमें ज़रूरी नहीं है कि हमें फाइनल आंसर फीट या सेंटीमीटर पर्टिकुलर में ही चाहिए होता है. वी नीड टू नो द एंड ऑफ द सर्वे दैट दिस इज दिस, and we can convert. Whoever wants to use that report, they can convert it into whatever they want to convert. But if we use, for some students we are using feet, for some students we are using centimeter, and then we compile that data, so there will be a large change in those, because for one person it is 5.5 feet and the other person it is 174 centimeter. For 5.5 and 174 are almost same. I think it is same. No, 166 is something 5.5. So 166, let us take, are almost same, but the numbers are are too much variable from one another, and that is how measurement error can occur there. So Satyam, you were giving us one example.
जैसे कि किसी ने मतलब जो बोला कि 1 फीट तो जो उसका फॉर्मूला होकर 12 इंच और उसने जो गलत लगा दिया, मान लीजिए 13 इंच ले लिया, मतलब वो कन्वर्जन में जो कुछ गलती कर दी.
Yeah, that can occur in measurement. And also that day I gave one example is, suppose we have to measure the blood pressure of some of a particular residential area. That the survey that we are conducting is to record the blood pressure of the people in living in my locality, and I go everywhere and I am using the measuring instrument or blood pressure machine that I am using is faulty. Then that can also result in measurement of error. Then that can give me variable errors, or the one who, suppose it is giving high blood pressure for everyone, so it has that fault. So for the person that is having the normal blood pressure also will be having high blood pressure. So in exam, when you will be explaining these measures, for one line you explain what are meant by them, and for the second line give example. That will do for this particular question. Then there comes interviewer error. What is meant by interviewer error is, suppose I gave a good example last time. Tell me, Satyam, what example did I give? And also, if you don't remember, tell me what are interviewer errors.
मैम जैसे अगर क्वेश्चन नहीं दूसरा पूछ जो हमारा ऑब्जेक्टिव है उससे हट के, तो ये इंटरव्यू
मैं बताती हूँ. So at that time, what I said was, when I am taking an interview, suppose I am the interviewer, and Manik, you are the one whose interview I'm taking, or who to whom I am asking question. And suppose I ask you, if I give you 10k, if the government provides you with 10k amount, then what will you do? And you are confused because suddenly you can answer something like that. So you are confused that what will you do, and you are just thinking about this, and I give you answer that you can use it to buy, you can use it for your study purpose, or you can keep it in your bank for further uses like that, and you answers, no, I will use it to buy a mobile phone. So even after asking you that particular question, I write the same answer that I wanted you to give. So if I, in the questionnaire, I write the answer as that he will use it for study purpose, instead of that you will use it for buying your mobile phone. So that is how I am making the questionnaire according to me and not according to yourself. And in many cases, because many of the people where in village areas and many other areas in modern cities also, people do not recheck what questions they have, what answers they have given with the interviewer. They totally trust them. So that is how where biasness can come on the side of interviewer, and this we can explain by giving interviewer errors. Understood?
yes.
Yes.
Mani? Okay, so these were the things that we discussed that day about the errors. Now we'll be talking about everything again today. So there were some questions related to this, as I told about this to Satyam. So there is one question from 2025 recently asked is, can you read this question, Manik?
Describe non-sampling errors and their sources.
And for how many marks has it been asked?
15.
So we have just mentioned 8. You can also increase them up to 15. Almost they are all, if you have observed it, they are same, but there are different headings. So you can add different headings and add much more. That is why we have discussed so many non-sampling errors. Okay.
Okay.
Then this PDF will discuss question later on this. Let us start with, I'm not writing this also again, so let us do this here also. On day 1, we were talking about simple random sampling with replacement. And I said that the probability of selecting any unit, uj, suppose I'm selecting, then it is 1 upon capital M, because there were n units of n population. And when I talk about sample, ith sample, if I want to select, there are total number of samples were capital N raised to the power small n. And for selecting one sample, it is 1 upon capital N raised to the power small n, where capital represents the population size and small n represents the sample size. Okay, this we discussed in the first session, just a quick revision. Then we were talking about notations. When I am talking about notations, this is sample mean. Small y bar is represented by sample mean and given as 1 upon n summation I goes from 1 to n small yi. Capital Y bar is population mean, which is represented as 1 upon capital N summation j goes from 1 to capital N yj. Then sigma square is known as population mean and is divided by capital N, and capital S square is also known as population variance and is divided by capital N minus 1. And Satyam was having doubt in this. So there were 2 days in between. Satyam, have you found out why there are 2 population variances?
मैम मुझे बस इतना पता चला कि वो एक्सपेक्टेशन ऑफ स्मॉल एस स्क्वायर वो सिग्मा स्क्वायर के बराबर होता है इसका कैपिटल एस स्क्वायर।
वो कैपिटल एस स्क्वायर के भी बराबर होती है, लेकिन देखते हैं। Expectation of small s square, you are saying? Yeah, it is both equal to capital S square and sigma square also. We'll do it. But why are we dividing it by capital N and capital N minus 1? Do you know, Manik, have you done sampling in your master's or bachelor's?
की है मैम।
बताओ फिर। यहाँ पे तो हम लोग इसमें सिग्मा स्क्वायर में तो वी आर डिवाइडिंग इट बाय कैपिटल एन, एंड एस स्क्वायर कैपिटल एस स्क्वायर में वी आर डिवाइडिंग इट बाय कैपिटल एन माइनस 1।
वो अनबायस्ड एस्टिमेटर होता है,
कौन सा?
इसलिए रिवर्स एस कैपिटल एस स्क्वायर।
सो हाँ बोलो बोलो।
मैम तो उन्होंने जिन्होंने सोचा होगा रिवर्स थिंकिंग करके कि अनबायस्ड जा रहा है तो इसको यूज करते हैं।
One of the reasons is this, that capital S square is the unbiased estimator of our population, of our sample variance. That is how we come to this conclusion by reverse thinking, which is correct by Manik. The other possible reason for this is that sigma square is known as true parameter. So when we are talking about sigma square, we are actually talking about the whole population, and when we calculate the variance, it is when we talk about the whole population. But can you consider that we will take every time we will take the whole population instead of some portion of it? Do you think that every time we'll take the whole population? Is it possible for us to take whole population every time?
No, ma'am.
So that is why we divided by capital N minus 1, such that there is some population even which is left, we subtract all of it, the total number of population by 1, such that the answer we get is unbiased and is also a representative of a true parameter, and also does not exactly represent whole population. If we have missed some of the portion, then it can cover that. So it is unbiased and also it is a representative of true parameter. This is true parameter and this is a representative of true parameter. That is why, because in most of the cases we do not consider exactly the total number of population that has been provided to us. And also while calculating, we'll come to the conclusion that whenever we calculate our variance by this and this, then obviously this will match with the sampling variance, and this will rarely match with the sampling variance. There are some conditions in which it matches, but mostly it will not match. Okay, and also
कैपिटल एस स्क्वायर के फॉर्मूले में जो वाई बार, कैपिटल एस स्क्वायर के फॉर्मूले में 1/n माइनस सेक्शन वाई आई माइनस वाई बार मीन।
Satyam, your voice is breaking very much.
हेलो हेलो।
Yeah, hello, we can hear, but after that, when you were speaking with continuity, then it is breaking.
मैम कैपिटल एस स्क्वायर का जो फॉर्मूला है उसमें मैम पॉपुलेशन मीन है ना, सुनाई दे रहा है?
हाँ हाँ,
हमें उसमें जो वाई बार है ना
का
वो
जो
पॉपुलेशन,
फॉर्मूला है,
उसमें जो है ब्रैकेट में वाई आई माइनस वाई बार का होल स्क्वायर है, तो वो जो वाई बार है मतलब पॉपुलेशन मीन नहीं है, वो सैंपल मीन।
this one, right?
यस मैम।
I have written it this. Yeah, we'll change it. It is capital.
तो मैम वो जो सैंपल मीन होगा तो इसका मतलब है कि हमें उसको एस्टिमेट करने के लिए, क्योंकि पॉपुलेशन मीन नहीं था, तो हमें उसको एस्टिमेट के लिए 1 डिग्री ऑफ फ्रीडम चली जाएगी, इसीलिए वो 1/n से करेगा।
No, I'm not getting you.
मैम जो 1/n-1 से डिवाइड किया गया है,
Hmm.
वो n-1 इसीलिए क्योंकि हमें वो पॉपुलेशन मीन पता नहीं होती है,
Hmm.
तो हम पॉपुलेशन वेरिएंस एस्टिमेट करने के लिए हमें यहाँ पे सैंपल मीन की जरूरत पड़ती है।
Hmm. इस वाले
तो
फॉर्मूला में
इसलिए
you
वो
are saying that it should be yj minus small y bar.
यस।
Array, it has gone again. So I will recheck this thing because according to me it is capital Y bar only. I have done it from Shalabh sir notes, so you can recheck it from there also. Then we'll discuss it tomorrow, okay, about this particular thing. So now sample variance is this represented by this. Then yt is y total, which is summation of yi's, and it is nothing but n y bar, and small yt is summation of small yi's, which is sample units, and it is small n y bar. This we were discussing last time, and let us move towards simple random sampling with replacement estimation problem. So first of all, let us discuss about simple random sampling without replacement, and then simultaneously we can do estimation and calculation of their variances because the formula is almost same for both of them. So when I talk about simple random sampling without replacement, so again there are y1, y2, y3 and so on up till yn population, n total population. And in there are units u1, u2, u3 and so on up till un. So suppose if I have to calculate the probability of selecting the ith unit, then what will be the probability? Can anybody tell me? Now we are talking about simple random sampling without replacement. If I am selecting ith unit at jth draw, ith unit at jth draw. Wherever you don't understand, just ask me. This is a simple probability question.
1/n minus j minus 1.
See, suppose the first unit at that I am selecting. Ith unit, for till ith unit, first, second and up till ith we have to go, right? So suppose I am selecting the first unit. So, but I don't want to select it. I just want to keep it aside. How do I tell you this? So suppose for the first unit, it is not selected. Selection of probability of selection of unit 1 is, let us say u1, but it is not selected. Then u1 bar. Probability of selection of not selection of u2 is this, and up till if I am selecting ui unit at jth draw. So at first draw, if I am selecting unit 1, what is the probability of selecting first unit at first draw? Total number of units are capital N, and I am selecting only first unit. So it will be 1 upon capital N, right? And if I don't have to select it, if I'm just selecting it and keeping it aside, but I have to move towards finding the ith unit. So then the probability of selecting first unit at first draw, probability of not selecting first unit at first draw will be 1 minus capital 1 upon capital N. Do you agree with me? Or is there a bit confusion? You can ask me if you're confused.
Many songs. Hello. Can you hear me?
Yes, Satyam, I can hear you.
मैम मुझे वो वाली लाइन समझ में नहीं आई कैसे.
देखो, when we are calculating that, we have to calculate the probability of selection of jth unit at kth draw, and we are using simple random sampling without replacement. So at first draw, I will select first unit. So suppose my first unit, probability of selecting first unit is u1. Suppose u1. At first draw I am talking about. These are draws and these are probability. So what will be the probability out of n that I have to select one unit?
मैम टोटल नंबर ऑफ पॉसिबल सैंपल इसमें जो है वो जितने होंगे 1/3.
We are not talking about sample, we are talking about units in a particular population.
मैम तो 1/n.
It will be 1/n. But here I am talking about that I have to select, I have to go up till the ith unit. And previous to that, I am not selecting any and I have to select only ith unit. Suppose there are 5 numbers 1, 2, 3, 4, 5. And this is ith unit. So if I take out for first draw, if I get 2, so I want to I will take it out, but since it is not replaceable, since it is simple random sampling without replacement, I cannot put back the number 2 in the box. So probability of sampling, probability of selection of 2 is equals to 1/5. But since this wasn't the one that I wanted to take out, so probability of not selecting it will be equal to what? 1 minus 1/5, which is 4/5. Now I am left with n minus 1 units, which is 4 units. At second draw, if I am taking out number 4, then probability of this will be 1/4. And probability of not selecting it will be 1 minus 1/4. And now 3 will be left out. And at the end, if I select ith, then it will be probability of selecting at third draw, and if I select the ith unit, then it will be 1/3. then this will be my selection, final selection. Now, have you understood it?
Yes.
So that is what I'm talking about. Ith unit at jth draw. So first draw we won't select, that is I have taken bar. Second also bar, and up till at the ith point I have selected the at the jth draw I have selected the ith unit. So that I will not take as bar. Before this, at the j minus 1 at draw, I will take bar. Now, have you understood the concept that what we are talking about related to simple random sampling without replacement? So here, now tell me, I have drawn this, or let us take it like this. Tell me the final probability that you will be getting here.
मैम U1 बार हो जाएगा 1 माइनस 1 फिर अगला वाला हो जाएगा 1 माइनस 5, फिर ऐसे ही करते
1
करते
minus 1 upon n, 1 minus 1 upon n minus 1,
n minus 1, ऐसे
and
डॉट
the
डॉट
last one
1 upon 1 minus 1 upon n minus j plus 1.
n minus j plus 1. N minus, yeah, it will be this.
मैम ये
This is
ब्रैकेट
the
में है, ये इसको ब्रैकेट में लगाइए 1 माइनस
1 minus क्यों? jth, अच्छा jth draw.
मैम जेथ को
We are
पहले मैम ये j minus 1 है,
okay, you are
ये
talking
पहले
about
वाला
j
है वो
minus 1. N minus j plus 1.
plus
But will it be n minus j plus 1? See it very carefully. Because for first draw we have taken n minus 1 plus 1. They have got cancelled. For j minus 1 plus minus 1. So it will be n minus j according to me. See yourself whether it is coming n minus j or n minus j plus 1. According to me, it should be n minus j only. I'll just keep it here now. If we are selecting first unit, so we have kept n minus 1 and plus 1. In place of j, just keep that. And we have got them cancelled and we are getting 1. N only. Then put j minus 1 there. And probability of selecting the ith unit at jth draw is 1 upon n minus
1
j
upon
plus
n
1
minus j.
plus 1 at this time. Now calculate and tell me the final answer that you are getting of this probability. Manik, you will tell me. How was sampling in your college days of you, both of you? How was sampling for you? Easy, difficult, moderate?
मैम मैं आपको पहले ही बताया था शुरू होने से पहले कि मुझे एकदम
Difficult लगती है.
बहुत कंफ्यूजिंग, बहुत डिफिकल्ट सब कुछ.
What about you, Manik?
लेंथी बहुत है, समझ तो आ जाती थोड़ी, फिर
हाँ.
जो बाद में जो मेथड है देख रहा है एस्टिमेटर, या हॉर्विट्ज थॉमसन बहुत लंबी लंबी डेरिवेशन।
जो अभी करोगे, जैसे कि अभी हम ये टॉपिक कर रहे हैं तो अभी ये समझ आ जाएगा, लेकिन जैसे जैसे हम इस टॉपिक में आगे बढ़ते रहेंगे, so you'll get more and more confused because everything gets intermixed, and there are also involvement of simple random sampling with and without replacement in many other methods of sampling, cluster and multi-stage, and every one of them there is a mixture of this, so you'll get more and more confused. So suppose we are doing this, so derive this, even this portion becomes very difficult in exam to attempt, so derive it as many times as you can with your own hand, not just by seeing it. Just see the notebook and close the notebook after that, and do the derivation by your hand. As many times as you will do it, your concept will become more and more clear.
मैम
Hmm.
मैम वहाँ पे जो 1 - 1/n - j लिखा हुआ है,
Hmm.
1/n - j, अगर वहाँ पे हम
Hmm.
j की जगह अभी रखते हैं 1,
Hmm.
तो मैम वो क्या हो जाएगा? 1 - 1/n-1, तो वो पहला टर्म नहीं है ना?
हाँ, it will be j plus 2. सॉरी, कब आएगा यहाँ पे? अब देखो, because we are decreasing
मैम
ना,
अब तो
n-1 and up till that, so
मैम
we
पहला
will
वाला
be
टर्म कैसे आएगा? उस j में हम क्या रख दें?
j में हम क्या रख दें? यहाँ पे हम j
मैम
minus
j में
1 टर्म ले रहे हैं ना।
अरे मैम, तो पहला वाला टर्म तो आना चाहिए। जनरलाइजेशन अगर कर रहे हैं तो पहला वाला टर्म कैसे आएगा?
हाँ, तो j
वन
minus
अपॉन है
1
तो
अगर n-1 आ रहा है, यस,
वहाँ
there is
पे मैम
something,
n-j+1 ही होगा, क्योंकि j=1 रखेंगे तो वो कटपिट के 1/n हो जाएगा।
n-j+1 होगा यहाँ पे।
हाँ मैम, जिसमें j अगर हम 1 रखेंगे तो पहला वाला टर्म आ जाएगा।
n-1 नहीं, देखो, अगर हमें jth टर्म चाहिए तो हमने लिखा 1/n-j+1, और अगर हमें फर्स्ट टर्म चाहिए तो हम j की जगह पे 1 रख देंगे, तो ये 1/n ही तो आ रहा है। अगर मैंने j की जगह पे 1 रख दिया क्योंकि मुझे फर्स्ट टर्म चाहिए, तो फिर -1 + 1 कैंसिल होके 1/n ही तो आ रहा है, जो कि यहाँ पे आ रहा है 1/n।
हाँ मैं समझ गया। nth टर्म पे देखिए।
This portion doesn't come in examination, this particular thing that we are doing, but for you to know that probability of selecting of ith unit and simple random sampling without replacement, how has it come, that is why we are taking it. So because it will be useful later on, I will tell you where it is useful. So have you calculated it, Manik? Tell me.
1/n.
Yeah, it is simply 1/n, the final answer, which is same as the one that we calculated for simple random sampling with replacement. I think it is not here. The second is one is there. Probability of selecting of jth unit of ith unit. Ith unit only we are
अच्छा,
selecting at jth draw. We can do it like this. I and bracket j. Then this is equals to 1/N. N. Because here draws also matter when we are discussing about simple random sampling without replacement. Now talking about the total number of samples present in simple random sampling without replacement. First of all, how do you think that we can find it?
मैम
Yeah.
मैम सुनाई दिया कुछ।
सॉरी
मैम क्वेश्चन क्या दिया आपने क्वेश्चन?
अभी मैंने क्या पूछा? Total number of samples in simple random sampling without replacement. How do we find that? Or if you know, then tell me the answer. In simple random sampling with replacement, we were talking about, and there are n samples. We always talk about small n as the total number of samples or the samples.
में अगर कैपिटल एन नंबर ऑफ पॉपुलेशन है और स्मॉल एन नंबर ऑफ सैंपल्स है तो वो हो जाएगा कैपिटल सी कितना
Sorry, capital
कैपिटल एन कॉम्बिनेशन
हाँ, it will be equal to NCN, or we also can write this as NCN. This is how also it is written. Do you want to do the derivation? Because it is not necessary, but if you want me to do it, then I'll do it. Otherwise, we'll move toward estimation portion. Manik, is it fine with you?
मैम एक आउटलाइन बता दीजिए
क्या?
मैम एक आउटलाइन बता दीजिए कैसे होगा बस
देखो, जब हम n samples, suppose I have to select ith sample at jth draw. Again, we'll take the simple thing. So here, the first time that we are selecting the first sample, the total number of samples upon total number of population units. Then the second time it will be n minus 1 upon capital N minus 1. The third time that I am selecting out of total, it will be n minus 2 upon capital N minus 2. And so on, it will come to 1 upon capital N minus j plus 1, the same thing. And when we do some of the things here, when we multiply and divide by some things, then this formula will convert to, as you can see already, the numerator is converting to n factorial and the denominator will convert to capital N factorial, and this will be by multiplying by something, it will be n minus 1. This is probability of selecting ith sample at jth draw. So it is concluding at 1 upon capital N Cn. These are total number of sample, and probability of selecting ith sample will be 1 upon NCN. So this is how, this is the outline. You can just do it, try it. If you won't be able to solve it, then we can discuss it further. Okay. So let us talk about the estimation of both of them. First of all, we'll talk about, also I am not being able to hear the voices of your thumbs up and raising hands, because in the app I was able to, but here since I cannot see screen continuously, so I am unable to see that. You can just unmute, and whenever I ask, you can unmute your mic and answer me. So talking about estimation, first of all, we'll be talking about the unbiased estimation or the estimation of our sample mean. So let us first talk about our simple random sampling with replacement. So when I talk about simple random sampling with replacement, so we have to find the expected value of small y bar. Can you tell me what comes as equal to this unbiased estimator of the sample mean should be equal to?
population
But how? See, I am deriving for it. If I open this bracket, I can write it as small n summation I goes from 1 to n yi. I can write this formula y bar as this. Now taking the summation inside, 1 upon n summation I goes from 1 to n expected value of yi. Now, when I talk about something like expected value of xi, Then the formula for this is, do you know the formula for expected value of xi in general?
मैम xi इंटू अगर वो डिस्क्रीट है तो फिर जो है उसका पीरियड समेशन इंटू xi इंटू उसका जो है प्रोबेबिलिटी मास, और अगर कंटिन्यूअस है तो इंटीग्रेशन xi इंटू पीरियड.
The very simple definition I'm asking, Satyam, not that much complicated. If I talk about expected value of xi, shouldn't it be like summation I goes from 1 to n xi into probability of selecting the ith unit of xi?
हाँ मैम यही तो बताया था.
हाँ, PDF में नहीं जाना अभी. Okay, so here we are doing same thing. When I talk about yi and I am talking about this, then we can write this as 1 upon n summation I goes from 1 to n. Now since expectation results in one more summation, so here we will take a summation again, but this time from J1 to capital N, because expected value of yi will be yi, capital Yi, into probability of selecting the ith unit in simple random sampling with replacement. That is why we have done is 1 upon capital N. Now can you see this whole formula and can you tell me what this formula is?
y bar population.
Capital Y bar, right? So now summation, now y bar doesn't have any I terms, so summation can reduce to n. So we have reduced the summation to n in the next step into n expected y bar. This n and n get cancelled and the final result that we are getting here is equal to capital Y bar. So population mean is an unbiased estimator of sample mean for simple random sampling without replacement. Have you understood this derivation? Very important derivation, many times I asked in the exam. In the PYQs also I'll show you how, where they have asked. Now tell me, when I talk about simple random sampling without replacement, what will be the changes here? The same derivation when I talk about the expected value of sample mean of simple random sampling without replacement.
कोई चेंज नहीं.
Manik, do you also agree or do you want to answer that there will be some changes?
मैम n फैक्टोरियल आ जाएगा शायद, कैपिटल N.
कहाँ पे? यहाँ पे?
Yes मैम.
Here what are we putting? This is what?
Probability
Of?
मैम yi की आने की probability.
Probability of selecting the ith unit of the population, not sample. We are not talking about sample, we are talking about the unit. That is why I made you do the derivation. And just now you have calculated probability of selecting ith unit at j draw is, what is the probability?
1 by n.
1 upon n. Same probabilities are there for both of them. That is why I made you do this. And hence here also this will be same and there will be no change in the formula. So both of them we can write, this is valid for simple random sampling with replacement and simple random sampling without replacement. Same derivation. Okay, and in the exam if they ask you that you have to derive both of them, then do it separately. Okay, chalo, let's finish up with the variance also, then we'll discuss some of the questions. Variance. if I have to derive, first of all, let us talk about in general first. Variance of small y bar, which is sample mean. When I'm talking about variance of small y bar, can I talk it like expected value of y bar minus expected value of small y bar whole square? Can I write it like this variance formula?
Yes.
And understand each and every step. That is how you are going to do it in exam. So when we do expected value, then expected value of small y bar, what do you think it is?
Ma'am, population में इनके parameter y bar.
Yeah, just now we have calculated capital Y bar whole square. Now just opening these two. If I am opening the small y bar, I can write it as 1 upon n summation I goes from 1 to small n small yi minus, if I am dividing and summing over 1 to n, can I write it like this? Do you have any problem in this step? We will do it very slow because this is confusing topic.
Yes, ma'am.
Now
ये y बार के साथ मैम ये y बार के साथ समेशन मैम y बार के साथ समेशन समझ नहीं है. अच्छा हाँ हो
अभी
सकता
देख ये n से n कट जाएगा ना, तो फिर मैंने दोनों को
हाँ so
now why have we done this, you will get to know soon. So 1 upon small n square I'm taking out common from both of them, and then we are left with expected value of summation also I'm taking common, I goes from 1 to n small yi minus capital Y bar whole square. Now do you know how do we open this term? So let me do it for you. When I open this term, it will result to 1 upon small n square. When I open this particular term, it will be expected value of summation I goes from 1 to n yi minus capital Y bar whole square plus summation j, and I is not equals to j, goes from 1 to n, both from 1 to n, we only write it once, yi minus y bar yj minus y bar. This is how we open the summation when it is given like this. Have you done this step before?
yes ma'am.
Okay, then let us consider this. Let us consider this as variance of y bar, and we'll put 1 by 1 in both of the simple random sampling with replacement and simple random sampling without replacement. Okay, this is what we have done. Let me just short it down. Then first of all, let us talk about our simple random sampling with replacement. When I talk about simple random sampling with replacement, variance of y bar is equals to 1 upon n square. Then expectation value inside, it is expected value of summation I goes from 1 to n yi minus y bar whole square plus expected value of summation I not equals to j goes from 1 to n yi minus y bar yj minus y bar. This is what we have done. Now can you tell me what is the expected value of yi minus y bar whole square? If I just do it like this, summation I goes from 1 to n and expectation I have taken here. Then can you tell me the first term, this term, what is meant by this term? Expected value of yi minus y bar whole square.
variance.
Yeah. This is sigma square. You can check the formula. This is sigma square. Summation I goes from 1 to n sigma square. Plus, when I talk about this, then can I take expectation individually, because we are talking about simple random sampling with replacement. So they both are individual units. Ith unit, drawing of ith unit and drawing of jth unit in simple random sampling. Do they depend on each other or they are independent? Tell me.
Independent.
Okay. Then when I talk about summation, so I can write in place of summation n minus 1, and I can take the expectation yi minus y bar and also the expectation yj minus y bar. Can I do this because both of them are independent?
Yes.
Okay. Then here it will be 1 upon n square n sigma square plus, when I solve this, tell me the answer of only this particular term. What are we getting? Expectation will go inside. On what term will the expectation act? And what will be the final answer?
एक्सपेक्टेशन वाई आई पे जाएगा, वाई बार पे जाएगा, तो वो जीरो हो जाएगा.
Yeah, it will be 0. This whole term will be 0. When I take expectation of yi, it will become y bar, and y bar minus y bar will be 0. Similarly for yj. So this whole term will become 0. You can do this on the side and tell the examiner. Now for solving this, this will be sigma square by small n. This is the variance of our simple random sampling with replacement. Now if I have to convert this into capital S square, then the formula is n minus 1 capital S square is equals to n sigma square. This formula is very important regarding your first and second paper also. So in order to convert this, this can be written as n minus 1. Let me see whether I'm writing it correctly or not. I have taken small n. It is capital N. So it will be capital N minus 1 upon n s square. This is usually the formula that we see in the final examinations, and this is how you have to leave the answer. Okay? Understood the simple random sampling with replacement portion?
Yes.
Now simple random sampling without replacement. For once I want you to try all these portion. This will be the same for simple random sampling without replacement, but this will change. There will be some value here. So do it by yourself. Try at least for once by yourself. And then tomorrow we'll be discussing it, whether you will be able to try it or not. We'll be discussing the same under simple random sampling without replacement. Yeah.
मैम वो वहाँ पे जो है तीसरे वाले स्टेप में, शुरुआत से दूसरे वाले स्टेप में इसी स्लाइड में मैम वो जो समेशन दोनों लिया उस पे n इंटू n माइनस 1 कैसा आया? y इज नॉट इक्वल टू g1.
जब i को मैंने n ले लिया तो j के पास कितनी वैल्यूज बची? बताओ. दोनों i भी 1 से n तक है और j भी 1 से n तक है, लेकिन ये दोनों एक दूसरे के इक्वल नहीं है. तो जब भी इन समेशंस को खोलेंगे ना, ऐसे समेशंस को, और अगर हम k भी ले लें, तो the summation, if I is taking one value which is n, then one value has gone for j because j cannot be equal to I. So the remaining values the j can take is n minus 1. That is why I have taken it. Now n can have different value. I have not taken n as 1 because if I just take a constant here, then I don't know whether I is taking 1 or 2 or whatever. So I have taken a variable which can be represented as small n. So I can take values 1 to small n, whatever values. And j, all the values that are remaining, j can take values from that. Now understood, Satyam?
मैम अगर पहला वाला समेशन एन वैल्यूज ले रहा है तो उसके बाद जो जे वाला है समेशन वो वैल्यूज नहीं लेगा, लेकिन यहाँ पे
वो
एक ही वैल्यूज कम कर।
एग्जैक्ट अरे नहीं, तो तुम कंफ्यूज हो रहे हो एन से। चलो सपोज हम आई ले लेते हैं, एन ना लेके। तो अगर मैंने यहाँ पे आई ले लिया तो दूसरे वाले के पास क्या बची, एन माइनस आई तो वैल्यूज बची।
अच्छा, उस समय वो वैल्यू नहीं लेगा, बाकी तो ले सकता।
हाँ, और वो मैंने आई को रिप्रेजेंट करने के लिए एन लिखा है, बस ऐसे लिखते हैं, ठीक है।
ओके।
And if there is k also, because sometimes it opens up till k, so when it is k, y k minus y bar, then it will be n minus 1 and n minus 2, like that. So I think that this is clear to both of you. And also try for simple random sampling without replacement. Let us discuss 1 or 2 questions related to the topics that we have done, so that you can try at your home. This time this question came. See, it is not the exact derivation, but there are some changes. So we'll discuss it after doing without replacement. This also came. We'll discuss it later. This also came. We'll discuss this later. You can see these 2 questions of 2020 that has been asked. Can you read them? Or shall I increase the size?
Define simple random sampling with replacement and without. In simple random sampling without replacement, show that the sample by is in estimate population mean, derive its variance, and also find standard deviation of the estimate of the population.
How many things I have asked in here? Okay.
3 things.
So the first portion is definition and unbiasedness of population mean is for 5 marks. Then variance is difficult for simple random sampling without replacement. That must be a 5 marks, and also the standard error of the estimate of the population total. Now they haven't asked about the population mean, sample mean, but of population total. So that also we'll be doing. Then you understand the last 2 parts. But first 2, I think it's easy. And second also, the variance also. The last portion we'll discuss it later. So these kind of questions come. Then the first question is, describe the advantages of sampling versus complete enumeration, the ones that we discussed in first class. Write the circumstances under which complete enumeration is preferred to sampling. Both of them both of the question has been asked, and it is for 10 marks. So I think you can write the answer for the same. We have discussed it. See here, 2018, explain sampling and non-sampling error. State the sources of non-sampling error. 10 marks, it has been asked for 10 marks. Now, can you read this question? If you can, you will be able to solve it. See. या एग्जैक्टली वैसे ही करना है। बस यहाँ पे हमें n और स्मॉल n की वैल्यूज मिल गई हैं, और स्मॉल yi की भी वैल्यू मिल गई है। ओके, इज इट ओके विद यू मानिक?
Yes, ma'am.
The questions that we are discussing that day, suppose the questions that I'm taking that these are there, those questions can be attempted. That is why I'm considering them. Also consider this question. This also can be attempted. This is the sampling variance for simple random sampling without replacement that you will try, and tomorrow we'll discuss that also, how the derivation is. Then this too we have done, this also. So try to do the questions that I have told you for today and do the derivation of simple random sampling without replacement variance. And also from tomorrow, I think the technical issues that has been on the app will be sorted by tomorrow morning. So we'll take the class there most probably, unless or it is okay here also if there are technical issues or there were some problems on this platform.
मैम ये तो ठीक।
उसमें बहुत ज़्यादा ब्लर हो रहा था ना, तो बहुत सारे बच्चों की सैटरडे संडेज भी क्लास होती हैं, तो तब भी हो रहा था, तो
हाँ मैम, तो इसमें तो
concluded
सही है।
that instead of blur class and ending it, then it is better to do it on other platform. So let's end today's session and try to complete the question for yourself, and wherever you will be having doubt, then we'll sort that out tomorrow. Okay?
ओके मैम।
Okay then, let's wrap up.